Want to crack interviews at FAANG and other top-tier tech companies? You can. With USA's #1 tech interview prep platform, you get access to 500 FAANG Plus experts, all from the world's leading tech giants. We've already helped 25,000 plus tech professionals land their dream roles. You could be next. Don't miss out. Register now for our free webinar and take the first step toward your FAANG dream.
So this is a mock interview session for data structures and algorithms, right?
Yes.
Okay. So how we would be going about this is, I think you have already got the, editor on the link, right? Okay. So you can share your screen with me.
Okay. I just shared my screen.
Yeah, I can see it now.
Okay.
Okay, so I'll be giving you the question over here. Okay.
Okay.
What
Okay.
you need to do, you need to tell me the approach first, and then you need to
Yes.
put the problem, and you need to give the optimized solution, and
Fine.
whatever base cases and edge cases would be there, you have to cover that as well. Okay.
Okay.
Let me give you the problem.
Sure.
Okay, so this is the problem.
Given an unsorted integer array numbers. Okay.
Hmm.
Sorted integer array. Return smallest positive integer that is not present in numbers. You must implement an algorithm that is on time and uses O1 space. Okay. Given an unsorted integer, return the smallest positive integer that is not present in numbers. That is not present in numbers. Okay. Okay. So, okay, I understand. As I understand, if array is already has all in numbers in increment, if array has all numbers, which if we sort it and see in incremental way, if there is no missing number, then we have to give next possible number. Otherwise, we have to figure out the missing number in that particular sorted array,
Yes.
right?
You have to just return the missing positive number, first missing positive. You can see the examples, right? For example, if
Yeah,
you see 1, 2, and 0, right? So what is the missing positive integer that we can have? Next missing integer that is not there, it is 3, right?
3.
Yeah.
Correct.
You don't have to take 0 or -1 into account, no negative numbers. Okay. So let's say if you have 3, 4, -1 and 1, then basically we are missing 2, right? So 2 is the output.
Okay, so in this second example, 0 is missing, right? So
No, no,
0,
sir. So I said it, na. Zero is not considered a positive integer, right? Zero
uh,
and negative numbers, you don't have to. Uh,
no, wrong. Okay, 0 and negative in your numbers, you can safely ignore simply.
yes.
Fine. Okay, let me just give me a couple of minutes so that I can think about
That's fine.
the solution.
Yeah, yeah, that's fine, totally.
Yeah, thanks. So, yeah, you cannot do sorting, because if you do sorting and then try to find out
Then it would not be an
it will
optimized.
not be optimized, because it will not
Yes.
come into ON.
Yes, yes, yes.
Minimum thing we will need for sorting O log n, and after that one iteration that is greater than ON. Then we have to consider something different. Thinking about it. Just give me some more couple of minutes.
Yeah,
not
yeah, you
able.
can take your time, you can think. It's totally fine.
Okay. One thing we can do, uh, getting one clue from the constraints. Constraint is it is 231. 231. A number can number can be between minus 231 up to plus 230. Okay. So negative number, how can I accommodate? I was thinking about having a because we have constant memory we can utilize. So if we use one integer, and if we just do the bit manipulations, uh, in that case we can identify the missing bit, and corresponding to that missing bit, the number is going to be that number. So this is one approach, uh, and in this approach, uh, so integer is 4 byte. 4 byte means uh, 4 bytes, and each bit represents 8. Each byte represents 8 bits. So
Uh-huh.
32 bits. No, so this is not sufficient because we cannot accommodate up to 230 bits here. So in that case, we have to take some large number. Uh, uh, and if we take integer, I just try to understand how can we do this with the bit manipulation. So 2 raised to 8 is
See. One thing I want to tell you, I think you are getting confused over here. It's not
uh,
105, it's 10 to the power 5, and 2 to the minus 2 to the power 31, 2 to the power 31 minus 1. Okay, these are the
oh it constant is it's okay 2 to the power 31.
yeah.
Okay.
Yeah, you were opening scientific calculator and everything, so I thought of
I was thinking how can I solve this with the bit manipulation.
yeah.
Okay, so now that is not in scope. That means so
Yeah.
this array size is up to 10 raised to 5.
Yeah.
10 raised to 5. Okay. So no, we cannot use this now. Then array. Okay, missing smallest is the clue here. Okay, I understand. So we have to given and unsorted integer array, we return the smallest positive integer that is not present in the numbers. Okay, so I think 1, 2. Okay, if in a given array we have to keep track of uh, this thing is smallest one. Consider this 3, then 4, 3, then 4 is the smallest. We have to take the latest one. 4 is the latest one. Then it come to -1. You can ignore this. Then it come to 1. Uh, we know that from 3 to 4. It can be anything like uh, then part 10, 11, 11, 4. I'm not able to figure out the solution. Can you please give me some hint?
Okay, so basically, what you should do is you should try to kind of, scan the array, not sort, scan the array. Okay,
Right.
and put the elements at their correct position.
Okay.
Okay, so scan, not sort. If you scan it, it would be O of n only. See, at
Okay.
whatever
We have to.
index, yeah,
Okay. That means, but what is the guarantee that number can fit into the size of the array?
that you would have to think.
Because this is the, if we consider
See,
this
honestly speaking, like if we talk about the smallest missing positive integer, right? Whatever is your length of the array, it would be in the range of one to n plus one only, right? Correct.
1 to n
N plus one.
n
N is
plus
the
1.
length of the array, right? Correct.
N is the largest.
N is the length of an array.
N is the sorry. N is the length of the array. Correct.
Correct. Then you have to, like when you are assessing the number at index, right? Okay.
Ah,
So you will place each number, let's say x, at index x minus 1. Okay. Right.
right.
And then just you have to scan the array to find the first index where that array position is not equal to I plus 1. That's it.
Uh, but if you consider x as this, if you consider this example here, 4 is x. Let's say
Mm-hmm.
4 is not fitting into the size of this array, right? Because size of if you
In
consider
which one it's not fitting? Which one it is not fitting? Which array you are seeing?
line number 12 here.
Yeah, no. So this is already in the array, right? 3, 4, minus 1, right? Correct,
Right.
right? So if you look out for a missing positive integer, 2 is missing, right?
Correct.
So you have to just scan the array, put every element at its correct position, and see where, that array position, like where you find a mismatch in terms of
But in that case, we have to take auxiliary array, right?
auxiliary array. Why?
Because this 4 will not fit in current, because current array size is 4, and if you want to put 4, and array size will, I mean, it will, the 4 will not be, we cannot put at index 4, right?
Yeah, correct. So, but we would not use the auxiliary array, right? Because we need to solve this in O(n) of time and O of one, constant extra space. So
uh,
you can't use auxiliary array. You have to do it without using that. So, okay, just take this example 3, 4, minus 1, and 1. Okay, where your 1 should come? Just tell me.
It should come at the place of 4.
No, no, tell me the index where you will keep it.
Current index is 3.
Where you should keep it. That's what I'm saying. To find the missing positive integer, I am saying that put the elements at their correct index position, right? Scan them, correct? So, ideally, where should 1 come? Which index 1 should come?
Put
It should come
uh,
at
put
index 0, right?
put the number at its correct index. In that sense, I mean, at the end of the scan, are we expected to sort this array?
No, we are not sorting the array. We are just doing the scan, right?
Yeah, we scan means we will just iterate through the array and read
Yes.
each element. Uh,
Yeah.
and if we start from 3, uh,
So at which
I'm
place,
yeah,
at which place you should keep 3? At which index you would
3
keep 3?
has to. Okay, if you are imagining this as a sorted array, 3 has to go at this -1 place.
Yeah, 3 should be at index. No, no, no. Just
Index
tell me the index
index
position.
2, index 2.
Correct. 1 should be at index 0, right?
1 should be at
2 should,
index 0. 4 should
4
be at
should be
index
at,
3.
yeah. Now swap the elements, right? Keep swapping the elements
Uh,
till the time each number is not at its correct place, okay, or you get out of bounds and ignored.
okay.
Okay, you have to swap, and that's how
So
you will get the,
but once we swap entire array, we have to again iterate it once to figure out the
no,
missing
no,
number.
no, it would be iterated only once, right?
We iterate it only once. So 3. Let's say I'm starting with
You have to do a linear scan.
linear scan. Right, right. Let's say I'm starting with 3. 3 has to go at 3 minus 1 means second index. So -1 and 3 will get swapped. My next
So
number is
if you
4.
see, if you just see where is the first mismatch. So if you see at index 1, right? Correct, at
Yes.
index 1, which is the value -1, correct, right? Right
Uh,
or not?
-1 is 2, right? Index 2.
-1 is at index 1, right? Index start from 0, correct? 1
Index
is at
start from
index
0.
0. 1 is at index 0. -1, 1 will come at index 1, right? 3 will come at index 2, right?
After scan.
Yeah, 4 will come at index 3, right?
Correct, correct.
Now, at which position? There is a mismatch, right?
Uh,
-1 is at index 1, right? Ideally, like at index 1, basically, the value should be 2,
2.
not -1, correct? Right? So,
Right.
this is where you get a missing positive. There you get a mismatch, and you have to return that missing positive. That's it.
But by the time we uh, okay, at the end of this array, end of the scan, we are already pointing to -1.
Yes.
So we can deduce it like index is less than array bound, and uh, if that index is greater than the smallest index of the array, then number is the +1 to the earlier index number. Is
Correct.
that the okay expected output? Okay, okay.
Yeah,
Now I
so
had
I think I have given you the enough it now, right? So
yes,
now you
yes,
just
yeah,
apply logic actually.
yeah, 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 yeah. So let me again iterate about the solution. Thanks you helped me to come with the solution. But let me iterate once again. We are going to
Mm-hmm.
scan this and we are going to swap each element. Uh, let's say first element, it is number 3. Then we have to put it at its correct index, so 3 will come to this place, minus will come to this place. Now 4 we have to swap to its correct index, because array size is itself is 4. 4 we cannot accommodate 4 at any place. So in that case, 4 will go at which place? So that is a
Why can't we accommodate 4? 4 will come at index 3, right?
yes, yes. 4 will come to index 3, because yeah, that is the correct. You are correct. Then we, 3 is already at its correct index, and 1 is, uh, but once we do uh, 4 with 1, in that case 1 will come here, right? 1 will come to index 1 and 4 will come to index 3.
1 will come to index 0, sir, not 1.
1 will, sorry, 1 will come to index 0. Okay, now we have to, and 3 is, but by the time 4 is 4 index of 4 is identified, 1 is already present at index number 3. So in that case, uh, 4 is swapped with 1, right?
I think again you are not understanding the context. You don't have to swap the positions with the indexes, right? You have to just put the element at the correct index. 1 should be at index 0, simple. 3 should be at index 2, right? 4 should be at index 3, correct? And you just from the index position, you just have to find, which element is not correctly placed at its index. That's it.
Okay. Yeah, fine. But in that case, we have to take auxiliary variable, right? Because if we want to
No,
put 3 at, uh,
why it is required?
let's say this example, if you want to put 3 at number 2, index number 2, then we have to keep this minus 1 at index 0.
No auxiliary array, no auxiliary variable, nothing should be used.
Okay,
Do it without that.
okay. Uh, let me think it once again. If I'm putting 3 at number index 2, in that case minus 1 will come to 0th index. This is my first swap. Now if I'm going to 4, in that case 4 has to go to index number 3, but 1 is already present at index number 3. Then where should 1 go? Ideally
So,
1.
like, just one thing I want to say over here. Even if you
uh,
take an auxiliary variable, let's say, suppose you take, okay, you
uh,
take a constant number of auxiliary variable, let's say, okay, how will
uh,
it change the time or space complexity?
Time complexity, it will not change. Space
Space
complex.
complexity, it would not change. Na? It will still satisfies the O of one space requirement, right?
Ha ha
You
ha
have constant number of auxiliary variable if you want to take, right?
ha ha. Right.
Yes. So you can take the variable, whatever. You can take few auxiliary variables. I don't have any issues. The time
Ha.
complexity, and you should solve it in this time and space complexity,
Correct.
irrespective of whatever you choose.
Okay. So what I was thinking is, first swap happened to 3 and minus 1. Second swap happened. I mean, swap is a correct thing here or not? That's I'm thinking about. So if we want to keep 3 here, if we put minus 1 into auxiliary variable, then 4 we want to swap with 1. 4, 3 came here, 4 to this place, and 1 goes to 4 place. then -1. And if I'm going with the swap cases, 3 and -1 swap, -1 came to 0th place, 3 came to index 2, 4 is going at index number 3, then uh, 1 has to go at index number 0, but at index 0, there is already -1 present. Then 4, it's quite a complex to track indexes here. Example 1 is straightforward, where there is no swap is required. But in example 2, if we move 3 to this place, what happened to -1? That is my confusion. And if we want to keep -1 at the swap place with 3, then -1 go to 0th place. Now our iteration start with index 1, where 4 number is there, and if you want to keep it at its correct index, then there is already 1 present. Now we know only 2 indexes. That current index is 1, and its right position is number 3. And if you want to swap this, then 1 come to index number 1 and 4 go to its correct index. Now we have to continue from same index, like 1, and we will not. Okay. In this case, 1 has to go to index 0, and the one which is present at number 1, number 0, that will come to here. Okay, this way we can solve it. Now I understand. Yeah, yeah. So, if I want to express this in a correct way, yeah. So this function will look like this. Integer, we have to return integer, and we have to smallest. Smallest. So vector of integer. So this is array. Say like this. size of this array. If I say loop if I is less than length, okay. Now what I'm going to do is I think we have to use a while loop to have better control over the incrementing the number. Extend this. Here we have to check if array of I array of I we have to verify its index. If array of I is not at its correct index, not equal to array of I minus 1, right? So here I'm checking its correct index. If it's not there, in that case we have to swap it to swap array of I with its I, sorry, comma. With this particular number, and we are not, in this case we are not going to increment the, otherwise we have to increment the number. So in this case we will, in next iteration we will start with the same. Now our we want to understand, okay, now there are two things here, cases. One is array of I has to be check array of I is within array boundary. Okay, if array of I, that number minus 1 is less than or equal to array length. This is one case. Then only, because array of 1 is already in this array of I, we know it's already here, and this we want to change it here, and after swap we need not worry about what is going into index I. This only we have to make sure we are swapping at the correct index, otherwise we are going to
Just I want to ask one thing. I hope you are enjoying the problem, right? Because see, in the
Yeah.
interview also you would be getting only one problem, right? And on one
Uh-huh.
problem only there would be a complete investigation, right? Once you solve it, then
Uh-huh.
the interviewer would be asking some more questions, right? So
Uh-huh.
make sure you at least practice lead codes,
Uh-huh.
medium and easy,
Uh-huh.
all the level questions, right?
Okay,
Because
okay.
that will make you pretty much confident, and
Correct.
this question has been asked in Amazon actually.
Okay, okay, okay. But yeah, I mean, with your help, I'm able to understand the solution.
I
Uh,
can give you a solution as well in 1 minute, but the thing is I want you to brainstorm to get that
correct,
interview kind of environment. That's it.
correct, correct, correct. And I'm getting that feel actually. Yeah, yeah. So so actually, I got the solution. So now I'm working on the implementation part, so that I'm not missing any uh, conditions. So I think up to this I'm good. Now my next uh, thing is I have to make sure uh, the item where I'm right now is a zero or negative. This case I have to check. So this case, but in the, let's say at very first place, if there is a -1, uh, in that case, should I? Okay, if very first, okay, if I array of i's, array of i's less than equal to 0, we continue here. The next index will go this, and when I exhaust uh, I think when I exhaust in that case, is last index, and that last index is swapped with some number. But where is my number? Which is, I think there is some condition which I'm missing here. Let me again go through my solution. Number is this 3 swapped with -1 came to position 0, 4 swapped with 1 came to this, and now my I is at 1, uh, I is at index. Now I swapped with -I, so we have to keep track of the index with which we have swapped. Okay, so swapped index is equal to, say, swapped index. This is swapped index. Once we swap here, we are keep tracking of the swapped index. Right. Okay. So when we exhaust the array, so each time we are going to swap, right, something, and when we exhaust it, uh, when we exhaust everything, we know the item at the swapped index is the item which is an unfit here. And if yeah, so if swapped index equal to array bound, that means length of the array minus one. So in that case, or we can say result and directly just return swap index plus one. Else uh, if this index is zero, uh, in that case,
Let me give you the solution for this, okay? And
yeah,
what I would suggest you now, basically just practice a bit more, okay?
yeah,
And even before keeping the mock interview, see, it's fine with me, right? You don't have to prepare each and every topic, right? Because when you're going for these companies, right? See, DP and
yeah.
tree comes afterwards. You would not be judged much on DP and trees, honestly speaking, but you have to be really good in terms of arrays, linked list,
Okay,
recursion, strings, searching and sorting. Because
okay.
in these topics, right, there's a wide variety of questions that can be created, right? Easy
Right,
as
right.
well, medium as well,
Because
complex as well.
and so do you mean to say trees, graph, DP have fixed set of patterns,
Yes, that's why.
and
Because
those can be remembered.
correct. In deep, you just need to know, right, where to apply, BFS, where to
Yeah,
apply DFS. If you have that knowledge, you would be easily able to solve any question,
solid.
right?
Correct, correct.
But this is where you will face the challenge, right? If the question is a bit tricky.
Yes.
So practice them a bit more, and people will not start asking DP at first go, right? First, they will
Uh-huh.
start with a simple data structure only or simple problem
Okay.
only,
Okay, okay.
and
That
then
means
time permits, they
first
can
round
go.
of interview or
Yeah,
first question, we can expect like anything from array, linked list,
yes.
string, sorting, and searching.
At least first round would be on these only. Second round, maybe you can be judged on bit of graphs and DP. Here and
Oh,
there.
okay.
Yeah, but
Mm-hmm.
this is about what I have faced when I have been interviewing with these Mangfang companies, right?
Mm-hmm.
So yes, okay. So yeah, I think like I know like whatever code also you have written, right?
Uh-huh.
There are some challenges with this code, but still,
Uh-huh.
like it's kind of like I would not say that it's very bad, but definitely there are chances of improvement for this as well, right? But
Yes.
it is okay after I have given you the hint. But
Huh.
make sure that we are not taking too much of time. I think we have taken a
Huh.
lot
Yeah.
of time, right? That is where,
Ideally, we were expected to do problems, right, in
yeah,
1 hour.
yeah.
Yeah, and I mean, even one is not completed. That means
Yes.
I need to practice more and more.
Yeah. So that is the thing. Even see, it's not that we have to give two questions only. It's not like that, right?
Hmm.
We can do only one question only. But one question I want to do end to end, right? You
End to end.
solving it,
Yes.
then I kind of putting some more conditions, then asking you
Ha
to
ha
again
ha.
do the logic. This
Follow-up
is
questions we can expect.
yes. Which I could not ask. I am not here like, okay, we did not cover second problem. That's totally fine,
Ha
right?
ha ha.
If I have to judge someone, I can judge them through one question only, and that's what company also does, right? Okay,
Okay.
so that is totally fine. But we were not able to do the follow-up questions as well. That is something should
Understand.
not happen from next time if we meet, right?
Okay. Okay. Understand.
So
Thanks, Dikshant. Yes.
yeah, no worries. I am a kind of Python, I have a Python background, so I've given this solution in Python, okay, which I
Actually,
solved.
I'm sorry. I changed this to C++. Actually,
Mhm.
I
What
don't.
you can do is,
Haha.
you can just use some kind of GPTs or that we have, right, Chat GPT or something, and
Haha.
you can convert this code into C++.
Uh, Actually, I'm not familiar with Python.
So you can use this to convert. Okay, let me convert it for you into C++ this time.
Uh, Okay, you are okay. You are already giving, right? Okay, okay,
Yeah, I have already given you.
okay, okay.
So I have given you
Fine.
the this
Python, I can make it out, but I'm
no,
not
I have given you the
proficient.
C++ code as well.
Okay, okay, okay. Fine. Yeah, got it, got
So
it.
this is the complete code. Now I'm sending it.
Yes,
Okay, so you can use this one.
yes.
Okay. Cool. I have to jump to another call, and please feel
Sure.
free to reach out to me if you have any further questions. You have my email ID with you. I would be more than happy to help you. Okay.
Yes. Thank you very much, Dikshant.
Thank you. Bye. Take care.
Bye.